Hello everyone. In this video, we'll be studying about or you can say we'll be deriving expression for capacitance of parallel plate capacitor partially filled with dielectric. Okay, dielectric slab. Right. So we'll be deriving it. Okay. Now consider this as plates of capacitor. Okay. Right. These are having charge. You can see this is having negative charge. Now a dielectric is being partially held inside it. Okay. Now you we have seen in the previous video. Okay, opposite charges will be induced, right? Here, your electric field E naught. Okay. Now, if you consider uh, this slab thickness as small d, okay, and your thickness of the slab as small t, and inside this electric field will be E naught by K, right? Now, you know that capacitance, this is Q upon V. V will be E naught into the potential that is being developed due to this air. You can say this is the air. Medium is air. Okay. It will be d minus t because the net thickness of the air is d minus t. Okay. Plus the potential developed due to dielectric, it will be E naught by k into its thickness is t. You know that E into d. Okay. This is your potential. So V will be, if you take E naught common, E naught, so d minus t plus d by k. Okay, this will be your potential. Now V will be, you can write E naught as q upon a epsilon naught d minus t plus t by k. Why? E naught will be sigma naught by epsilon naught, and sigma naught can be written as q by a. Now C will be q upon v. That means this q and this q will cancelled out, and you will get a epsilon naught upon d minus t plus t by k. This will be your capacitance for a partially filled dielectric, where T is your thickness of dielectric, T is the distance between plates of capacitor, and A is your plate area. Now we'll discuss some special cases. Suppose if entire space is filled with air, that means T equal to 0. Okay, then C will be, it will be epsilon naught A by D, which you know, C naught. If entire space is filled with dielectric, okay, that means T equal to D, then your C will be, it will be k epsilon naught A by D. That means k into C naught, means k times the C naught, which is C naught is actually the when your thickness is 0, means there is no dielectric. Okay. Now case number 3, if instead of dielectric a metal plate is placed, metal plate is placed. Okay. Then remember one thing, for metal plate your K will be infinite, so your C will become epsilon naught A upon D minus D, because there if you put K equal to infinite, this will become 0 and your capacitance will become epsilon naught A upon D minus D. Right. This is your case number 3. Now case number 4, this is the most important one as well. If multiple slabs having thickness T1 T2, let me write, multiple slabs having thickness T1 T2 T3 and so on. Okay. And dielectric constant K1 K2 K3 and so on are placed. Okay. Then what will be your current capacitance? Okay. So let's say the plate 1, slab 2, slab 3, slab 4 and so on. Okay. T1 T2 T3 and so on. Okay. Your equivalent capacitance then will be C is equals to epsilon naught A upon D minus, your T will be replaced as T1 plus T2 plus T3 and so on up to where we require, plus your this term will be replaced by T1 by K1 plus T2 by K2 plus T3 by K3 and up so on up to where the question is asked. Okay, this will be your equivalent potential. Okay, and if entire space is filled with the dielectric having T1 T2 T3 and so on, then this will become 0 and your equivalent capacitance will be epsilon naught A upon T1 by K1 plus T2 by K2 plus T3 by K3 and so on. Right. So this was about the expressions for parallel plates when dielectric is filled. Okay, and these were for special cases. The most important one is fourth one. Right. Thank you.